Okay, so let's try to understand the merge sort algorithm. Uh, it it is a divide and conquer algorithm. Okay, so this code is available on Geeks for Geeks. It's in C. Now we would mainly be working with three functions. One is this void merge function, which takes the parameters array left, like the leftmost index, the mid index and the right index. This will be used to merge the array at the end, and then we will be working with this function called merge sort, which is kind of a recursive function which will keep calling itself, and then we will be working with the main function in which we would just like put the array and stuff. Okay, now first of all, let's try to understand how the merge sort algorithm works. So this is an array and it has various values. It's an unsorted array. The merge sort algorithm sorts the array in ascending descending order depending on how we use it. It's a divide and conquer algorithm. What it does is it divides the biggest problem to the smallest possible subproblem, and then it merges it. So we have this entire array, we find the midpoint, we break it into halves, and then we keep doing that. We keep breaking it into halves continuously until we have the lowest possible breakable point, and then we merge the sorted array. So basically the goal is such that it is easier to sort smaller problems than to sort an entire problem. It is a recursive algorithm, so it does have a lot of space complexity, but yeah. So it uses divide and conquer approach, and it basically uses the fact that merging sorted array is easier than merging unsorted array. Now it just basically does this. It breaks it into this is the smallest piece, right? So it compares 20 if 27 is 38 is smaller than 27. It basically swaps it, merges them together, and then basically we have this entire merging. Okay, now coming back, let's understand how this algorithm or how this code is working. So I have taken this array as an example. So our example array is 4, 12, 1, 13, 5, 16, 7. The size of this array is 7. This is the size of the array. Now let's get the code once more. So see, it calculates the size of the array. Now this is the printing part and the normal part, so the main function doesn't really have a lot of things. It calls this function called merge sort. Okay, so this is the recursive function that we were talking about. So what it does is it goes into this function. This is a very important function. Now how do I make this visible? Okay, so it calls the merge sort function, right? So what we are essentially calling is merge sort. Then we are passing this array, this entire array. I'll be just doing this. We are passing this array, and then we are passing the index 0, n minus 1, which is basically the index of this last variable. So we're passing the first index and the last index, which is 6 for our case. So this is what we are passing through the function. Now let's see what this function does. This function first of all compares if left is less than right. Why does it do that? Because when the indexes will become same, like when it's the smallest part, like when we reach the smallest subproblem that suppose is 4, only 4 is there, then the index will become 0, 0, which means 0 is not less than 0, so it will just break, it will return, the recursion tail will end. Now what happens in this case is we have called this function, and now we come here, so it checks if left is equals if left is less than right, which means it checks if 0 is less than 6, which it is, so it proceeds. Now what it does, it calculates the mid. How does it calculate mid? It calculates left plus right minus left by 2. This is done to keep it within the bounds, like so that it does not exceed the limits. We could have just done it the normal way, like plus and then the entire divided by 2, but we use this so that it does not exceed the bounds. So we have 0 plus 6 minus 0 divided by 2, which is 0 plus 6 divided by 2, which is equals to 3. So we calculated the middle index. So now we have the current middle index at 3, which means 0, 1, 2, 3, that is 13. So 13 is our current index. So what it will do is it will break this array into this part, and it will send it to the first function, first recursion call. Yeah, I guess we can call it that. So what it does is now it sends it to merge sort, then the same array is sent, not gonna repeat that, left, in this case the left index remains the same, the mid index becomes 3. Right, now the next step would not be executed right now. Once this step is executed, it will again return back to this step, it will return back to this line. So what will happen is, now that we have sent it back to this line, it will again check if 0 is less than 3, it will calculate mid, which is equals to if we calculate it, it's gonna, okay, so yeah, so it then calculates the mid, which is 0 array, which is 0 plus 3 minus 0 divided by 2, which is basically 3 by 2, which is 1. So now the current mid is at 1. So it then again calls the same merge sort function. So it calls merge sort, then the array, the same array by the way, 0, 1. Now we again come back to this step, and then we again check if left is less than right, which means we check if 0 is less than 1, which is true. Then we calculate the mid again. In this case it will become 0. So now the left and right indexes are the same. However, we will move to the next step, like this first merge sort. So we will call merge sort the same array, and then the index is 0, 0. So now the left and mid index both are the same. Now these get transformed into the left and the right index. So we get back to this line again, and now while we are again comparing this, the thing gets crossed out. So now what will happen? Now let us understand the recursion trail. These were the methods that we called, right? So the recursion trail, this was the first thing that we called. So for ease, I will make the recursion trail like this. since this is the first thing we called, so we will do ms0 of 6 is the first thing we called. Then this called so this this function now first called this, so it's ms03, sorry about that, and then this called ms01, this called ms00. Now 0 couldn't get through, right? So this if condition was not satisfied. So what will happen is this ended. Now we will get back to this function. So we will input this, and we know this part is done, so we will go to this portion of it. Now what was the right index that we passed for this case? Okay, so now understanding the recursion tree, as we can see, the thing gets stopped at 0 0, and then it gets back here, and then we have the 1 1. So for 0 1, it gets the mid plus 1, so that is 0 plus 1, 1 1 gets sent. So when both of these are sent through, like both of these come and they return, like they're done, they are dusted. Now we have this function, which is our merge function. Okay, so this is a merge function. So in here we have 4 parameters. One is the array, one is the left index, one is the mid index, and one is the right index. What are we sending through the left, mid, right index? The left index in this case is, I guess, 0, and the right is 1, है ना? हाँ. So the left index is 0 and the right index is 1, and the mid index is again 0. So what we are sending after the 0 1 stage, matlab when these two are done, this function is calling merge the array and then 0 0 1. So it is sending that 0 0 1, it is sending, as well as the entire array it is sending. Now let's see what this function does. So in this function, this is the entire recursion tree, by the way. Let's understand. We are at this stage right now, and we have passed on to the merge function. This is not a recursive function, by the way. This is a normal function. The merge sort is a recursive function. So we have passed the parameters, the array parameter, and then the left index is 0, the middle index is 0, and the right index is 1. I, j, k are the iteration variables. We have just initialized them, and then we have taken n1 and n2. These are the sizes of the temporary arrays. These two are temporary arrays that we will be using to store the variables. Now n1 is the size of the the left side of the left part of the temporary array, and the right part of the temporary array size will be stored in n2. How we are calculating it? We're calculating it using the mid minus left plus 1. So let's calculate it. Mid is 0 minus left plus 1, so the size is 1, and in this case also the size is right minus mid. Right minus mid is once again 1. So now that we have created two arrays using these two sizes, we have created two arrays of single element arrays, temporary arrays. Now we are going to copy the elements of the array. So you have sent the indexes. In this case, in our case, it's 0 and 1. So we will copy till 1. So this one loop here, array the left index plus I, so 0 in this case. So the left index mein whatever is there, which means 4, will get transferred in the left array. So left array currently has 4 in it. 4 because it's the first element, it's the 0th element, and then in the right array we will store 12, which is the first element. The mid value is 0, so 0 plus 1 1 plus j 0, so yeah, and then again we have re-declared the variables. So I equals to 0 and j equals to 0, and then the k variable is taken as left. Okay, so the k variable is the left index. Now we will compare the temporary arrays and then we will merge them into one single array. So we will compare if the left array element is less than or equals to the right array element, and if it is less, then we will add it to our main array of k. We will add the temporary element from the left array, and then we will increment the index of the left array, like the I is counting the index of the left array, and if it is not less than equals to, then we will increment the index of the right array and we will put the element of the right array into the array. Now once when we are done doing this, we will do k plus plus. Now k is the counter index of the last merged array, the array that we are merging at the end. So that, okay, sorry. And then we will come here and copy the leftover elements. If we have any elements that have not yet been put into the array, then we will copy them back using this part of the code, and that is how it ends. Now once we complete this merge function, we will again return back to this. So we did the first part of it, now we will do the second part of it. Now the second part of this is this, and the same way as we did for this one, we will return to the single element array, and then we will return back to the second part of this, which is this, and then that is how the recursion tail works. So this is the working of merge sort. Now this is the code that I copied from Geeks, and I added some lines in the merge sort function to understand how it is working, for better understanding. So I haven't really done anything here. So these are some things that I've added. Now this is the output rate. Let's study how this is working. So I've put an iteration counter. So first we have the actual array that we input, and then it's sending through merge sort 036, and then part 1 basically means this. As you can see, I've labeled this as part 1 and I've labeled this as part 2 to understand which part is being called. And then I've also put the iteration number at the beginning over here, and I'm also printing the indexes that are getting passed through each iteration. So this is how the output looks. As you can see, this is everything that I explained, and I've also mentioned whenever the merge function is getting called. So as you can see, when it became a single element, the merge function got called after the 4th iteration, and then we are checking if 4 is less than 12. If it is, so we have the merged array, and then we are going to the part 2. So all the part 1 is getting called, and then we are calling the part 2, and then we are again getting back to a higher node of the recursion tree, and then the same thing is getting repeated, and that is how the merge sort algorithm is working.